Hi everyone, Mrs. Below here. In this video, I'm going to be going over the Dalton's Law notes. This is Dalton's Law of partial pressure for gases. So up until this point, we've been talking about like one gas in a container at a time. Now we're going to start talking about two gases in a container at a time, and in relation to pressure specifically. So if you have the pressure of one gas, so for example, this oxygen has a pressure of 159 mmHg, and you have a pressure of nitrogen gas at 593 mmHg. If you combine the two together, then the total pressure will be the combination of those two pressures. So how the formula looks in a simple way is like P1, or you could say PO2, like whatever your first gas is. If it's a gas that has an actual like name, you could do this, plus our second gas P2, or we could call this N2 because we know what gas it is, equals the PT, which is the total pressure. So this is one way to illustrate that concept and also the equation, like how I have right here. So partial pressure is the pressure of each gas in a mixture. Remember, a mixture is going to be, you can have a mixture of a lot of different things. You can have two gases mixed together. You can have a solid and a liquid mixed together. We're just talking about gases for this part of our notes. So Dalton's law is the total pressure, PT, is equal to the sum, so adding all of the partial pressures of each gas together. And you can have multiple gases. In this example, I only had two. So here's an example of that. So it says a tank contains 3 gases. Here are the 3 gases, and all of them have a pressure in ATM. So I would just have to add all those together to get them into ATM. However, if your pressures have any different types of units, then you will have to convert those units because you can't add different units together. So for example, a tank contains 3 gases. So we have carbon dioxide, carbon monoxide, and hydrogen gas. And then it actually is giving us the total pressure to begin with. So the total pressure is 434 torr. And then it says the pressure of the carbon monoxide and the hydrogen gas are both 112 torr each. And then it says, what is the pressure of the CO2 in ATM? So all of these added together are going to give me the total pressure. However, I need to find this in ATM. So you could do this one of two ways. We could convert all of these into ATM. So then our answer will be an ATM. Or I can go ahead and do the math with these since they're already all in torr, and then convert my final answer into ATM. So there's actually 2 correct ways to do this problem. You just have to make sure the things that you're adding together are in the same units. So since in this case we're solving for this one, okay, I'm going to set it up like this. So we have our total pressure, which is 434 torr, and that's going to be equal to these 3 added together. So I have 112 torr, or here we'll go in order. So I have X, which is what I'm solving for, plus 112 torr for the CO, the carbon monoxide, and 112 torr for the H2. So 434 torr equals X plus 224 torr. And if I want to get x by itself, I'm going to subtract torr from the 224 torr from each side, which would be 210 torr is going to be equal to x. But we wanted the answer in ATM, so I'm going to go ahead and take that amount of torr and I'm going to convert it into ATM. 760 torr equals 1 ATM. So I have to divide by 760. So my final answer will do 4 significant figures, 0.2763 ATM. And again, you could have converted all of these into ATM to begin with, and then your answer would have been an ATM, and then you wouldn't have had to convert at the end like I did. So you can basically solve a variety of different ways. In this problem, we were looking for the total pressure, and all of the units were the same, so we just had to add them all up to get the total pressure. In this one, the units weren't the same, so we had to do some converting. And I wasn't solving for the total pressure, I was solving for the partial pressure of one of the gases. So now the next thing we're going to talk about, which is a little different, so to separate those two concepts from each other, is collecting a gas over water. So this up here, that was an example of using this law. So the total pressure is just equal to the sum of all the gases, partial pressures of the gases added together. And then now we're going to talk about collecting a gas over water. So we've been talking about dry gases. If you collect a gas, if a gas is collected over water, then that has to be factored into the calculations. And we can do this a couple different ways. So earlier when we were talking about a dry gas, okay, that was like, H2 or something simple. But now, if you're collecting it over water, you're going to have water vapor present. And that water vapor is a gas, and it's going to exert a pressure. So instead of talking about a bunch of dry gases being added together, now we're talking about adding together to find the total pressure, the dry gas, okay? So whatever that gas is, maybe it's O2, maybe it's H2, whatever. And we have to add it with the pressure of the water vapor to get our total pressure. So now we're just talking about a dry gas, whatever that is, with water vapor, which is also a gas because it's water vapor. It's water in the gas form. And the apparatus is going to look something like this, where you have this tube. It could be a test tube or a different type of tube in water. And then you're going to basically pump a gas into here, and it's going to displace the water and push it out of place. We're going to do an experiment like this with an ediometer, where as the gas goes up into the tube, it's going to push the water out of the way and collect. And you can then measure the volume of that gas, which we'll talk more about later. So here's the formula. So you're going to use this formula if a question is asking about a gas collected over water. So again, it's similar to this, except we're collecting over water. And it can also look like this as well, where there's a reaction going on in here that's producing a gas. And that gas is going into this, and it's displacing the water. So in this space, you have the water vapor, and then you also have your gas. And then, so how do you find the pressure of the water vapor? Well, as long as you actually know the temperature, if you know the temperature of the water in degrees Celsius, of course. So this is the one time we're actually going to be using degrees Celsius, but it's just to find something on a chart. Then you will actually know its pressure. So let's say that I measured the water temperature and I was like, okay, it's 23 degrees Celsius. then I would actually know the pH2O, which is the pressure of the water. And this chart provides it in, this is what you get on your equation sheet, and it's being provided in mmHg and kPa. In the next video, I will go over these 3 example problems.